Absolute value equations and inequalities. Absolute value is the distance away from 0. So for example, the absolute value of 2 is 2, because on a number line, the number 2 is 2 jumps away from 0. The absolute value of -2 is also 2, and I'm sure many of you knew that because you have been taught that the absolute value of something makes it positive. And if we look on the number line, -2 is also 2 jumps away from 0. That's why the absolute value of -2 is also +2, because absolute value talks about distance, and distance can't be negative. So now we're going to start solving equations with absolute values. In this box over here, I want you to remember that the absolute value of something cannot equal negative numbers. So when we go back to looking at the problem and we look, we have 4 times the absolute value of x plus 1 equals 13. And so what that means is that once we get this absolute value sign by itself, it cannot equal a negative number. So that's the whole key to this first, is we want to get the absolute value sign by itself. So the first step that we need to do is we need to subtract 1 from each side. So subtract 1, subtract 1. Cancels that out, and I'm still left with 4 times the absolute value of x is equal to 13 minus 1 is 12. And the next step to get rid of the 4 is we want to divide each side by 4. So now we have the absolute value of x is equal to 12 divided by 4 is 3. Now here's where it gets a little different. X equaling 3 is not the complete answer. We have the absolute value sign by itself, and it equals a positive number, so we can continue to go. Once we have that by itself, we have to break it into 2 different options, because we are now saying x can equal +3, but x can also equal -3. And if over to the side, I'll explain that. So if I were to plug in 3 into this problem, absolute value of 3 does equal 3. So yes, it works. And then if we plug -3 in, the absolute value of -3 does still equal 3. That's why absolute values will have 2 answers. So both of these answers, x equals 3 and x equals -3, they are both my answer. Now to graph it on the number line, here's how you're going to set up your number line. You're going to put one of the answers, so the -3 goes on the negative side to the left, +3 is going to go on the positive side to the right, and then pick any number you want that falls in between. And I'm just going to pick 0, because 0 is always in between a negative and a positive number. So I've labeled my number line. Now I'm going to graph it. And because these are just equal signs, they're going to get a closed circle. So closed circle at -3 and a closed circle at +3. And that's it. There is no shading involved in equal signs, just a closed circle. All right, now we're going to do another example. So again, the whole goal is we need to get these absolute value bars by themselves. We are not allowed to ever distribute with an absolute value sign. So this is saying 2 times the absolute value sign. So to get rid of multiplication, we are going to divide each side. So now that gets rid of the 2 in front, and I'm left with the absolute value of x minus 1 equals 10 divided by 2 is 5. Absolute value sign is by itself. It equals a positive number. So I'm going to continue. Here's where I get to split it into two problems. So I'm going to take whatever's on the inside. So we have x minus 1 equals 5. So whatever we see, that creates one problem. The second problem is going to be the opposite of the equals. So we have x minus 1 equals negative 5. And that's it for the setup. Now we just solve each equation for x. So add 1 to each side. We get x to equal 6. Add 1. And we get x to equal negative 4. So both of these are considered answers. X equals 6, x equals negative 4. Now the last step is to graph it on my number line. So my smaller number, my negative one in this case, is going to the left. So negative 4. My bigger number, 6, goes to the right. Any number you want can go in the middle. Let's just put 2, because 2 does fall in between. And now since they are both equal signs, where x equals 6, I'm going to give a filled in circle. And then at negative 4, a filled in circle. And that's it. We have our solutions in our graph. All right, we're going to do another example. So here, the absolute value bars, they are all by themselves. Perfect. I don't have to do anything, except now I have to check, does the absolute value sign equal a positive number? No, this one equals a negative 8. So since it equals a negative sign, we would say no solution. And you don't have to graph it. But again, this works because the bars, the absolute value bars, are by themselves, and it still equals a negative number. So no solution. Okay, now you're also going to have absolute value signs with inequalities. And it's the same setup as we were doing with the equal sign. It does get a little bit different when we break it into two, but we're going to go through those. Okay, first off, I have my absolute value bars. They're by themselves. I don't have to do anything. Now, absolute value bars with inequalities, they can have a negative sign on the other side. Equal signs are the only times we can't. Okay, so back to this problem. Absolute value bars are by themselves. So I'm going to split into my two problems. The first one is what I see. So I have 2x plus 1 is less than 3. Now, for the second one, we take the inside, so 2x plus 1. Now, to set up, we need to flip our sign, so greater than, actually, let me do that in a different color. So it's going to be greater than negative 3. So we have to flip the sign and take the opposite number for inequalities. And that's the only difference. Now we're just going to solve each side. So we're going to subtract 1. Cancels that out. We have 2x is less than 2. Divide by 2. And we get x to be less than 1. So there's one answer. Same thing on the other side. We're going to subtract 1. Cancels that out. We're left with 2x is greater than negative 4. Divide by 2. And we get x to be greater than negative 2. So we still have our two solutions. And we're going to set up our number line. So again, smaller number goes to the left. So in this case, it's negative 2. Bigger number goes to the right, positive 1. And you can pick any number that falls in between them. I'm just going to pick 0. Okay, now with graphing inequalities, remember, we get a little bit different. We have to first check what kind of circle. And over here, we're just going to recap. Less than and greater thans, they have open circles. Less than or equal to and greater than or equal to, they have closed circles. So you just want to remember that when you're graphing inequalities. So for this example, both get an open circle. So -2 gets an open circle, +1 gets an open circle. But because they are inequalities, we also have to have shading. So for this one, I want to shade where everything is less than 1. So 0 is less than 1, so I'm going to shade towards 0. And then the same for the other one, I want where x is greater than -2. Well, 0 is greater than -2, so I'm going to go towards 0. And so anything in between these numbers, if you were to plug it into the original equation, it would work. All right, we have our next example. Again, our absolute value is by itself. It's okay if it's a positive or a negative number because it's an inequality. So since my absolute value sign is by itself, I can split it into my two problems. First problem is exactly what I see. So I have x plus 3 is greater than or equal to 2. Second problem, I take the inside, x plus 3, and we're going to flip our sign, which I'm going to change the color for. So flip the sign, and we're going to make it a -2. So these are my two problems I'm going to solve now. So to get x by itself, we're going to subtract 3. Right, and I get x to be greater than or equal to 2 minus 3, which is -1. So there's one answer. Again, subtract 3. And we get x to be less than or equal to -2 minus 3 is -5. All right. So now, I'm just going to move this up. I'm going to set up my number line. Smaller number goes to the left. So between -1 and -5, -5 is your smaller number. So that's going to the left. -1 is going to go to the right. Now I can't use 0 in the middle here because 0 is bigger than all of the negatives. So I need to think what number can fall between -5 and -1. I'm going to pick -3. You could have picked -2. You could have picked -4. Any of those would have worked. Now I'm going to graph my solutions. So at -1, I want a closed circle because my inequality is an equal to. It's greater than or equal to. And at -5, I also want a closed circle because it is another equal to. And because it is inequalities, I have to shade. So this first one, I want where x is greater than or equal to -1. So I want to go towards the numbers that are bigger than -1. -3 is not bigger, so I'm going to go away from -3. And then I want where x is smaller than, x is less than or equal to -5. Again, -3 is not less than -5, so I want to go away from it. And then that's it. You have your solutions and you have your graphing. Now, something to remember with the graphing whenever we're doing our absolute value inequalities is that your arrows are either going to both go in to each other or they're going to go away from each other. They aren't going to go in the same direction. So that's just something to remember when you are graphing it. So if you ever graph one of these and the arrows are going in the same direction, it's wrong. They're either going to both go towards the middle or both go away from each other. So again, if you have any questions with the absolute value with the equations when there's an equal sign, or with the inequalities when you have your greater than or less than signs, you can email me or come see me at Bulldog Block.